I'm going to talk a little bit about the special right triangles. So in our trig section, there are three angles that we worry about the most: 30-degree angles, 45-degree angles, and 60-degree angles. Now, we don't talk about them as 30, 45, and 60. 30 degrees is a sixth of 180 degrees. So we think about it as a sixth of half a circle. 45 degrees is a quarter of 180 degrees. So we think about it as pi over 4 radians, or half a circle cut into quarters. And we think about 60 degrees as half a circle cut into thirds. But for just thinking about where these angles come from and how they relate to the sides of their triangle, I'm going to think about them as 30, 45, and 60 degrees. So the first thing I have here is an equilateral triangle. This is 60 degrees, this is 60 degrees, this is 60 degrees. If I measured how long this length is, it looks to me like it is about 9, almost 10 centimeters. I'm just going to pretend like it is 10 centimeters. That means that this one over here is also 10 centimeters, and this one over here is 10 centimeters too. That's an equilateral triangle. That's what equilateral triangles look like. If I take this equilateral triangle and I cut it right in half, and I brought a compass, so I'm able to cut it right in half. Let me cut it in half really quickly for you. There we go. Connect here to here. Straight edge is not quite long enough. There we go. I cut it right in half for you. What I did is I just created a 90-degree angle right here. And I cut this 10 centimeter side into two lengths of 5 centimeters each. And so if we ignore this half of the triangle now, we have a 60-degree angle, we now have a 30-degree angle, and we have a 90-degree angle. So we have a 30, 60, 90. And the way that this side became 5 is because we cut 10 in half. So this side is called the hypotenuse, because it is opposite this 90-degree angle that we just created. And this side right here is going to be our smallest side. And the reason why it's our smallest side is because it's created by our smallest angle. If you made this angle a little larger, say 60 degrees, then it makes the side opposite of it a little longer. So this 30 degrees controls our smallest side. Our smallest angle in this triangle is now 30 degrees. So our smallest side is down here. And you'll notice that our smallest side is a half of the hypotenuse. How do I say that using trig terminology? I say the sine of 30. Now you might have memorized sine to be opposite over hypotenuse. And if we just follow that rule, you say opposite 30 is a 5 centimeter side, and the hypotenuse is a 10 centimeter side. Well, what I like to think about is I like to say sine of 30. Oh, I'm being asked, how is the side opposite 30 degrees? How is the smallest side in a 30, 60, 90 triangle, how is it related to the hypotenuse, the longest side? So if I told you that the side opposite was 3 centimeters, could you figure out the hypotenuse? I bet you would. I bet you would say, oh yeah, it's 6 centimeters. If I told you the hypotenuse was 50 centimeters, could you figure out how long the smallest side was? Well, it used to be 50. And then what do we do to it? We cut it in half. So I'm just asking for that relationship between the side opposite 30 degrees and the hypotenuse. How is the side opposite related to the hypotenuse? It's half the hypotenuse. So instead of calling this 10 or 6 or 50 and calling this 5 or 3 or 25, we just think about a 30-degree angle as having the side opposite of it be half the hypotenuse. So if I just call it half, then I can call the hypotenuse 1. So if this is 1, the side opposite 30 degrees is a half. So the sine of 30 is a half. Now, this other side right here, this height, that is opposite the 60-degree angle. It's going to be a lot longer than 5 centimeters because it looks longer than 5 centimeters, and also because it's opposite a 60-degree angle, and our 5-centimeter side was opposite a 30-degree angle. So a little bit larger angle is going to create a little bit larger side. So if we did the Pythagorean theorem, we would say 5 squared plus our height squared equals 10 squared. When we solve for h, we get 5 square roots of 3. So how does that compare to the other sides? It's the small side, but root 3 times larger. So it is larger than the smallest side, which makes sense because it's opposite a 60-degree angle instead of a 30-degree angle. Well, how did we get the 5 in the first place? Well, we cut the 10 in half. So this side right here, the one that is opposite 60 degrees or adjacent to 30 degrees, is going to have a length that is the hypotenuse cut in half and then multiplied by the root 3 by root 3. So we call that root 3 over 2. You could say it's the square root of 3 divided by 2, but most people just say root 3 over 2. That's how most people say that. So where is this root 3 over 2? It's opposite the 60. And root 3 over 2 is bigger than a half. And 60 is opposite root 3 over 2. And 60 is bigger than 30. So big angle, big side, opposite. Small angle, small side, opposite. So if I ask you for the sine of 30 degrees, I'm asking you for how is the side opposite such a tiny little angle related to the hypotenuse? So you could draw a picture, I suppose, or you could just think, oh, that's a very small angle. If my choices are a half or root 3 over 2, I'm going to choose the smaller value. Now, if I ask you for the sine of 60 degrees, you might say, oh, that's a very large angle compared to 30 degrees. So opposite of 60 degrees is not going to be half the hypotenuse. Opposite of 60 degrees must be this other value, root 3 over 2. And what's great about radians is it doesn't matter if I put this 30-degree angle in the first quadrant, or I put this 30-degree angle in the second quadrant, or I put this 30-degree angle in the third quadrant, or I put this 30-degree angle in the fourth quadrant. You can still tell they're all 30 degrees because of the pi over 6. This is a pi over 6 short of half a circle, which would be 6 pi's over 6. This is a pi over 6 more than half a circle. And this is a pi over 6 short of a full circle. So they all have the same height, a half, a half, a half, and a half. Because opposite 30-degree angles, you're going to have a side that is half the hypotenuse. So no matter where you put it, the side opposite a pi over 6 angle, whether it's the 5th one, the 7th one, or the 11th one, or the first one, opposite is going to be a half. So if I say, what's the sine of 5 pi over 6? A half. What's the sine of 11 pi over 6? A half. What's the sine of 7 pi over 6? A half. The only problem is these two halves are going down. So we should probably put negatives. So the sine of 7 pi over 6 is not quite a half. It's actually negative a half. Just a little extra detail to add in there. Adjacent is root 3 over 2. Root 3 over 2. Because that's the one that's opposite 60. That's the one that's opposite 60. So if I ask you for the cosine of 30 degrees, you say root 3 over 2. It's not going to be a half because a half is opposite. So if I ask you for the cosine of 30 degrees, you're thinking about, okay, well, opposite 30 degrees, that's going to be a very small side. So next to, cosine means adjacent over hypotenuse. How is the side adjacent to 30 degrees related to the hypotenuse? Well, the side opposite 30 degrees is a half of the hypotenuse. So the side adjacent to 30 degrees, that can't also be a half. It's got to be the root 3 over 2. And we can do that in any quadrant. The cosine of 7 pi over 6, that's just a 30-degree angle. So opposite of 30-degree angle would be a half. I didn't ask you for opposite. I asked you for adjacent. So it's not a half. So it's got to be root 3 over 2. The only little detail is 7 pi over 6 goes to the left. So that will be negative because the adjacent side would be negative. So our answers are always going to be either a half or root 3 over 2. And then you just have to decide, well, am I going up or down, or am I going left or right? And that will change whether or not you put a negative in front of it. Opposite of 30 degrees, whether it's the first one, the fifth one, the seventh one, or the 11th one, is a half. And sometimes that half is down. Next to 30 degrees is root 3 over 2. And it's either to the right or to the left. Now, if we do the same thing with 60 degrees, now opposite 60 degrees is root 3 over 2. And next to 60 degrees is the side that's opposite 30. It's a half. So the sine of 60, how is the side opposite 60 related to the hypotenuse? It's root 3 over 2 times bigger. It's the same as the cosine of 30, because the side that's next to 30 is the one that's opposite of 60. So the cosine of 30 degrees is the same thing as the sine of 60 degrees. They're the same value because we're talking about the same side. The side that's opposite 60 is the one that's next to 30. So over here, this would be, this is a third of a half a circle. This is 2/3. So that'd be 60 degrees. And now our ups and downs are positive root 3 over 2. These would be negative root 3 over 2, negative root 3 over 2, but it's still all the same values. If you wanted to talk about a 45, 45, 90 triangle, then you start with a square. This is where 45, 45, 90 triangles come from. You start with the square. In a square, all the angles are 90 degrees. And when you cut that square in half, you create a 45, 45, 90 triangle. Now, what's cool about a square is if this is 10, then this has to be 10. And so the side opposite 45 degrees is the same as the side adjacent. So how is the hypotenuse? Well, if we do the Pythagorean theorem, we get 2 100ths. So when we take the square root of that, we get 10 root 2. So the sine of 45 degrees is 10 over 10 root 2. Now we got a lot of cleaning to do. I don't like the 10, so I'll reduce that. We need to rationalize the denominator. And so we just memorize that opposite a 45-degree angle, it is root 2 over 2 times as big as the hypotenuse. So how is the side opposite a 45 degrees angle related to the hypotenuse? It's root 2 over 2 times as big. So not quite as big as a 60-degree angle. That would be root 3 over 2 times as big. Not quite as short As a 30-degree angle, that would be half as big. It's right in the middle. So 1/2 is opposite a 30-degree angle. √2/2 is opposite a 45-degree angle. And √3/2 is opposite a 60-degree angle. And it doesn't matter if these 30-degree angles are in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, that length will still be a half. Sometimes you're going down. These ones are the pi's/4, and these are pi's/3.